present about user association in multi-tier networks using particle swarm optimization. Here is the outline. User association is the process of selecting a user and which base station it should connect to. So we should select the optimal choice. And user association can improve the spectral efficiency, energy efficiency, and balance the load. In the traditional scheme, which is about the maximum SINR, users are attracted to the macro base station, and the small cells are lightly loaded, and this is a big problem. 3GPP introduced the concept of cell range expansion, where in cell range expansion a bias is added to the received power so that more users are attracted to the small cells and less to the macro cell. The CRE is a practical approach since it only adds a bias which does not need a uncoordinated decision. Here is the system model and the network parameters of the simulation that has been done. It was based on the round-robin scheduling algorithm, and the traffic model is a full buffer. We consider two interference cases. The first one is same tier interference, where a user receives interference only from the same tier, and the SINR is provided by this formula, and A is the subset, is the set of all base stations in the same tier, and this is the formula of the biased SINR. In the other case, the interference is from all base stations, and the different SINR is calculated. The throughput calculation is based on the 3GPP truncated channel model, where a user receives a zero throughput if the SINR is less than 1.8 dB, and it receives a throughput of 4.5 bit per second if the SINR is greater than 21. Otherwise, it is based on this middle equation. Particle swarm optimization is an iterative and fast searching algorithm that was developed based on the idea of pairs flockings and pitch scoring. In PSO, there are two main equations, which are the velocity and positions, and particles update themselves by using these two equations. The idea of using PSO is, instead of generating a static bias, we generate dynamic bias, because the static bias is not an optimal choice. And the function to be optimized is the cell spectral efficiency. Here's the algorithm that uses PSO. First we initialize, we generate the velocity, positions, number of iterations, and then we go starting by the first iteration, we add the bias, then we calculate the spectral efficiency of each particle. After that we compare the newly generated particles with the best particles that has been generated. After that we compare the best particle positions with the global best positions, and we replace the global best positions if the best particle position achieves higher spectral efficiency. After that we update the velocity and positions of each particle. At the end we return the global best positions, which is the biasing factors for the base stations. And here are the PSO parameter settings. As you can see, the number of iterations, swap size. Here are the results for the first case, which is about the same, using different frequencies, where a user receives interference only from the same tier base stations. And here is the cell spectral efficiency, and that one is a zoom in to see the figure more clearly. And here's the box plot for the biasing values that is being generated by PSO. And here are the number of users that are connected to each tier. As you can see, in the first case, which is 0 dB, and this is the traditional case, a lot of users are connected to the macro because it provides higher received signal. And as we increase the biasing, the number of users that are connected to the macro are decreased. And the last one is about PSO. We can see that the PSO achieves a better performance in terms of cell spectral efficiency. In the second case, where the user receives interference from all base stations, here is the cell spectral efficiency, and the PSO also performs better in this case. Also, as we for the static biasing, the optimal one is achieved by the static biasing, and as we increase the biasing, the spectral efficiency decreases. Here is also the box closer for the biasing level, by biasing values and the connections. Here is the future work. One way of we are working on a cell-less architecture, which can be defined in one way, that a user can receive from multiple base stations, and our next step is to associate users to more than one base station. Conclusion: user association can improve the spectral efficiency, energy efficiency, and balance the load. Cell range expansion is a practical approach. PSO can be used to generate dynamic biasing values and improve the spectral efficiency. PSO has outperformed the static biasing, and the next step will focus on associating users to more than one base station. Thank you, and any questions? Yes.
In the scenario, you consider the same transmit power for?
Yeah, it is a fixed power transmission.
Yeah, I mean, with the fixed power transmission, how can you extend the scenario to consider one user is associated with multiple base station?
So you can.
I mean that. If you consider equal power control from all base stations.
No, each base station, the small cell base stations have different power, and the macro has a different power. Pico has a different power, so there will be a different association methods.
Yes, I see. And now you only consider one user associated with one base station, right?
No.
No?
Many bases, yeah, many users can connect to one base station.
Here, how one user only served by one base station?
Yeah, at this scenario, only one user, yeah, a user is served by only one base station.
Yeah.
And the next scenario will be associating one user with multiple base stations.
Yes. And how can you get the optimal subset of base station connect with?
Yeah, this is the problem. It will be a hard problem to do, to associate a user with multiple base stations and select the base stations, maybe only one base station, maybe two, maybe three. This is to be figured out and solve this problem.
Yeah, I think it's easier to solve than only let one base station serve one user.
Yeah, it is easier to solve a one user base station association, but for a better performance, we have to associate a user with multiple base stations, because you will find users are at a dead zone or something, and some users are suffering and they need a lot of resources. So we just connect them to more than one base station.
No, my viewpoint that if you let the multiple base stations serve one user,
right,
and then the optimization problem is become compact program, and it's easier to solve than if you only let one base station connect with the one user. One user served by one base station, because in that case it's combining the real problem.
You mean connecting a user to multiple base stations is less easier than?
Yeah, easier to in terms of solving optimization problem. Yeah, we can discuss later.
Offline.
We can go offline.
For me, what I have, based on my understanding, is that connecting a user to multiple base stations is more complex than connecting it to only one base station, because you want to find the optimal base stations that a user can connect to. In only one scenario, in one base station association, okay, this is the base station, you connect to this base station. You don't have other choices. But in multiple base station, maybe it will be 1, maybe it will be 2, maybe 3. It depends. You have to figure out and which objective functions you are optimizing.
Yes, how, normally searching the best one is, we have to do some route for search the best one. Therefore, in terms of optimization, it's more complicated than when we search for subset base station. Yeah.
I kind of understand what he's saying. He's saying that if you try and optimize to associate one user to one base station,
Right.
if you try, it's like a brute force search at that point, because you're trying to associate it to the best, or like how you're trying to do it, and it might become a bit more difficult than trying to associate it with multiple base stations at that point.
No, but one user base station is it will take only the bias and it will add the bias and it will generate, it doesn't need any complexity. It will add the bias and it knows, okay, this is my best station. This is my best station that I will connect to. It doesn't need to be smart.
Okay.
But in the case of multiple base stations, it has to be smart and it has to decide, okay, this one, okay, I will take this 3. Okay, no, I will take this 2. Okay, I will take this 4. So in this case, it will be more complex. But
Right.
this is what based on my understanding, but we can talk later about it.
Yeah, go on, if you want.
Sure?
Yeah, no.
You start talking, so...
No.
Yeah, come. No problem for me.
There's no problem for me. Okay. What are you, so you say you're going to optimize. Okay. What is your main parameter for optimization? Is it going to be based on the network load, or is it going to be based on the perceived quality of service? What are you going to optimize in terms of like selecting the multiple base stations?
Yeah, the objective function is about maximizing the cell spectral efficiency. This is the main objective. Yeah,
Okay.
it can be extended to multiple objective functions, but in this case, only cell spectral efficiency is considered.
Okay.
Me now?
Yes.
It's in your simulations was the downlink, uplink. What are you
Downlink.
considering? Downlink only.
Yeah.
Do you believe that it's gonna affect the uplink, because if you connect it to the same base station, it's gonna be?
Well,
have in your mind to
another
do
way,
a joint?
Yeah, this is a cell-less architecture can be defined as associating one user to multiple base station. Another way of doing a cell-less architecture is separating the uplink and downlink, and this is what people are just starting to do, and this is to be considered in the future. I haven't done this.
I mean, in the user association,
Yeah.
to choose the best base station that the user should, or the base station choose the best user, or the users choose the best base station. You have to consider also downlink and uplink. This is because, okay, the decoupling things, and it's something Alex is working on that, and everything in the future is gonna be okay. But now you have to in the same base station. Thanks to Alex. In the base station now you have both downlink and doubling, so you have to start. I don't know, maybe of course you start from downlink and you're okay, but I'm asking if you are thinking to start working also in both, let's say a formula with joint downlink and doubling calculation and user association.
Yeah, that can be done.
It's gonna be also.
Yeah, it would be a better scenario to consider both uplink and downlink.
Yeah, but I think it's gonna be a joint solution, a joint formula. It's gonna be more realistic to your, because user association is something extremely interesting, and it's based on SDN. It's gonna optimize very much the network. It's very good work, but we have to consider all these things in real aspects, with real factors.
Yeah,
So
actually this work is not complete and we're still in the progress.
I'm sure. So you just start. I can fully understand.
We will take your feedback and develop our system accordingly.
Actually, it's not a comment on your work. It's suggestions, let's say,
thank you.
to your work.
I think adding on to his point, there's something of a suggestion on like a flexible RRC control, because right now the RRC is like, if you look at LTE dual connectivity, what they say is that the control plane is anchored at the macro cell, whereas the small cells, they do the data shower, or but they're trying to look at, basically try to have a flexible RRC. So, if the small cell is better for your control plane, you can actually associate the control plane to your small cell and, have the data plane somewhere else or things like that. So it might be interesting for you to, look at I think the release 13, the Feb 2017 document has that specification. So if you have a look at that, that would be really interesting.
Okay. Thank you.
Any control plane on the small cell?
Yeah, they're talking about flexible RRC because right now it's banked only at the macro cell, but they say that because there can be a scenario where you have a small cell which is very close, but you're on the edge of the macro cell, and so the control plane link is not
control plane. Okay.
Yeah, it's not good. So it might be better to attach to a small cell at that point, but then that introduces a lot of other issues with that. So I mean, they are talking about it, no solution, nothing is given, but I read in the document that they have of release 13 recently, so yeah, that might be interesting.
Any more questions? Anyone?
Okay, I have some comments about the presentation. Yeah. Basically, I think I found two main problems.
Right.
One problem was a little bit the structure of the presentation. And the other one was the detail you provided during the presentation. For instance, when I talk about the structure, for instance, at the beginning you started with an introduction.
Okay.
Not however, in the previous presentation, what we said is that perhaps your introduction on 5G. I mean, if you're talking about mobility, the introduction on 5G, perhaps it was a little bit long, etc.
Yeah.
In your case, it was a little bit different. I mean, it was the opposite actually, because you didn't talk about 5G in general.
Yeah.
That's okay. I mean, you need that. I mean, everybody knows that. yeah, everybody knows that. But the problem is that you simply said that talk about cell association.
Yes.
You include the slide. I could not, and I couldn't read it completely because there was a lot of text, and you passed it very fast. Yeah, and there was the typical draw of the cell range expansion, etc. So basically, note, you started explaining your solution, but the problem, the challenges, why, for instance, what happens, which is the problem if the bias is too small? Which is the problem if the bias is too high? Because, okay, if the bias is too small, then, okay, less users are in the small cell, so perhaps you are underusing the small cell. But if it's too large, which is the problem?
Yeah.
Because basically you are proposing something which is dynamic. So it means that in some occasions a low value is appropriate, and in some others a high value is more appropriate, more convenient. So try to show these challenges, why this, that, and then you say, okay, so we conclude that with a fixed value we are not being, let's say, optimal. Okay? And then you go to your proposal. And you go to do your proposal, and for instance, you started by saying okay, I don't remember the particles form optimization. That's okay, but how does it work? I mean, which is the concept behind that? Why did you choose this? Just simple word. I mean, so even without going into the details of the optimization, even without going into, let's say, the background theory that you had to learn in order to properly use this algorithm, you can explain which is the problem, which is for instance, this kind of this optimization tool or this optimization algorithm, which is the power of this, which are the strong points of this kind of optimization tool. Then you can say, okay, and this is why we use it in our problem, because our problem has these problems. So the flow is a little bit more simple, and then just something formal that you tend to, for instance, to split in order to fit more things into one slide. You divide the slide into two. It's like double. Don't worry. I mean, include another slide. If it's needed, include it, because perhaps some of the equations were not necessary. Okay.
One last comment on it's on the presentation,
Yes.
actually. I mean, I feel that you could have done all of this with diagrams, just diagrams. Because yours was a very physical, it's a physical layer aspect of some, like, it's not exactly, but it's not physical. I mean, let me finish. It's not exactly physical, but then you can give a representation of like what you're trying to do, and with like diagrams. So I sort of felt that you could have done it with the diagrams rather than have, like, I think Professor said it that it was you had too much text and you could split it. But if you had just diagrams, you could have. I think you would have conveyed it much better, and that would have put you at ease of like explaining all the things together.
Okay. No more questions. So I think it's the lunch, yeah. And there are 2 presentations for the after the lunch, yeah, for the afternoon. Okay. Thank you.
Thank you.